The second big key piece of technology that's created this sort of new renaissance in AI in the last sort of decade is called deep learning. And deep learning is to do with hierarchical neural networks. So they're kind of, you can think of them as loose approximations to the way our our real neural networks work in our brain. And here's an example of a neural network working. So imagine that you're trying to train one of these neural networks here on the right, these layers of neurons, to distinguish between pictures of cats and dogs. So what you would do is you would show this AI system many thousands, perhaps even millions, of different pictures of cats and different pictures of dogs. And this is called supervised learning. So what you would do is you'd show them pictures. You'd show the input layer at the bottom here, this picture, the raw pixels from this picture of a cat or a dog. And then this neural network would process that picture and then would ultimately output a label, either a guess saying, I think that's a cat, or a guess saying, I think that's a dog. And depending on whether it was correct or incorrect, you would adjust, the neural network adjusts the weights between these neurons so that next time you get asked a question about this is a cat or this is a dog, you're more likely to output the right answer. So, and it uses an algorithm called backpropagation to do that. So it goes back and adjusts the neural network weights depending whether you got the answer right or wrong, so that you're more likely to get the answer right next time. And once you do this incremental learning process many thousands, perhaps even millions of times, eventually you get a neural network that is really amazing at distinguishing between pictures of cats and dogs. In fact, better than I am, because I actually can't tell whether that's a cat or a dog from that particular picture. So one of our big innovations at DeepMind was to pioneer the combination of these two types of algorithms. So we called this combination rather logically deep reinforcement learning, and we use deep learning to process the perceptual inputs, to process the observations and make sense of the world out there, these visual inputs that the system is getting. And then we use reinforcement learning to make the decisions, to pick the right action, to get the system towards its goal. So we pioneered this sort of field, and one of the big things that we demonstrated was we built the world's first end-to-end learning system. It's called DQN. And what we mean by end-to-end is it went all the way from raw perceptual inputs, in this case pixels on a screen, to making a decision about what action to take. So really it was an example of one of these full systems that can go all the way from processing the vision to making a plan and executing that plan.